Okay, I'm back. Now, as I was saying, these are the tables that tell us a little bit of information about the lines. All right, what we want to know is whether these are proportional relationships or not. All right, there was something in the last block, I think it was block 3, talked about input, output. A little bit, I'll be honest, a little bit hard to understand the way that they're wording it. If they talk about multiplying the input value to get the output value. But basically, like if you had that one really easy one, like y equals 2b, you know, like if you plug in 2 for b, well, that just means that you just have to double that to get the number of yellow cups of yellow paint. So it was just a very easy input this number and you get the answer. But when you had like the delivery charge, you had to plug in the number, multiply it, and then add. Well, that's a second step. So that was not proportional. So the easiest way I can think to answer this question, to be able to see which is a proportional relationship, is to see which one just goes right through the origin, goes right through the middle of the graph. So like B does, see how there's a 0, 0, and D had a 0, 0, but these other ones had, you know, an extra 7. Like that's going to go through the 7 on the y-axis, that's going to go through the 4 on the y-axis. So the answer to A was B and D. If I was to plug in a 1, I would get 7. If I plug in a 2, I would get 14, and those are all proportional relationships. The other reason was that the ratios were all equivalent all the way through. If you looked at A and C, you know, like 1/11th is not the same as 2/18ths. For C, 1 over 7.5 is not the same as 2 over 8. Okay, so hopefully that kind of makes sense. For letter B, when they talk about it being non-proportional, when a relationship is non-proportional, it's not as easy as just multiplying by the input value to get the output value. So which tables would be non-proportional? Well, since B and D were proportional, then A and C are non-proportional. All right, then what they wanted you to do was actually draw the graphs for A, B, C, and D, just given the points. I've already done A for you. You know, if they say 0 and 4, we'll just go 0 and 4. We have to go up 4. Now, remember, you can label these however you want. I would recommend numbering them. Because I drew my graph like this, and I knew I'd have to go up to 18, I didn't really want to go 1, 2, 3, 4, 5. I don't even think if I started down here I would have 18 to do. I might, but I guess I hadn't counted. But you could go up by 2s. So I was just going 2, 4, and making that my point there. So that's 0, 4. And then what I did for 1, 18, since I'm also going to go by 2s on this, I could go in the middle here, and that was 1 and 11 for that one. And when I was doing on the other video that ended up not working, I just went off the chart there. It really doesn't totally matter. I don't care. You can go 2 and 18 and just go up there somewhere. As long as it falls in the line, that's all that matters. 2, 18. Okay, that's what your graph looks like for A. And they recommended using different colors. I mean, if you want to, sure, go for it. But I just drew a line and then drew an arrow, say that's line A. And for B, you'll do the same thing. I'll plot 0, 0, and then I'll plot 1 and 7. So I'll go over 1 and up 7. I'll put the dot there, and then over 2 and up 14. And then you'll draw another line there. And we just want to kind of compare all of these. Okay, now for letter D, it's going to ask you which graphs represent relationships that are proportional. Well, we had already answered that for A. We'd already answered that for A, so we could tell by the table and we could tell by the graph that since it goes through 0, 0, it is proportional. B and D are proportional. That is what they're asking for letter D over here. You can tell by looking at the graph because it goes through the origin. Now, the slope of each line, I had already done the one for A. Remember, to find slope, you have to look at 2 points on that graph. Now, we know of 2 points here for line A. We could, we always want to go up and over. So see from this point to this point, how far up and then how far over. And I believe it was up 7 and over 1. So our slope would be 7 over 1, and that just means divide, so 7 divided by 1 is 7. All right, going back and forth here. I would do the same for B. When I've drawn that line, which I didn't yet, I would again just look at my slope that way. Or remember, you can also, as we talked about constant of proportionality, you can always do y divided by x. So as long as it's a proportional relationship, you can just do it that way. You could do 7 divided by 1 or 14 divided by 2. All of those would be the slope. Okay, and that happens to also be 7. So same slope for B. And you just do the same for C and D. Same for C and D. Okay, now for, number 5. Mario's Pizza sells medium pizzas for $5.50 and $1.50 per topping. All right, so this one is kind of like when we did the pizza and then the delivery, except that we're only selling one pizza. We just want to know how different it is, whether I put 1 topping on or 2 or 3. Okay, so if I don't put any toppings, if I just get a cheese pizza, that's not considered a topping, so we're just going to pay $5.50. If I add 1 topping, like pepperoni or something, then I'm going to add, it says and, so we add another $1.50 to that, giving us $7. If I add 2 toppings, it'll be another $1.50. That'll be $8.50. If it's 3 toppings, like sausage, pepperoni, and onions or something, then that's 3 sets of $1.50 added to the $5.50 to get $10. Now, when I go to graph this one I didn't do on the previous video, maybe I can do that here. It's going to seem odd, but you can graph this, all right? If it says 0 and 5 think of that as 5.5. So if I'm doing these by ones, we could go 1, 2, 3, 4, 5, and then 0.5 would be kind of in the middle. Then 1 and 7. We'll go over 1 and then up 7. 1, 2, 3, 4, 6, 7. And then 2 and 8.5. So that was 7, so that's 8, 8.5. And then 3 and 10. So that's going to be 9. It's going to go off the chart a little bit like that, as long as it falls in line. Okay? That's how we graph those points. Again, put arrows to indicate that this goes on forever in both directions. All right, now the tricky thing about the algebraic rule, well, I shouldn't just flat out tell you that it's tricky, but remember, we have to think about the thing that's always the same. Okay, the thing that's always the same is that we've got $1.50. It's not $1.50 for 1 topping and then a different amount for 2 toppings and a different amount for 3 toppings. It's $1.50 per topping, all right? That is our coefficient. So the cost of this pizza is $1.50 times the number of toppings. So that's the N for that one, not the number of pizzas, but the number of toppings. So $1.50 times the number of toppings plus the 1 cost for the pizza. So that's going to be your algebraic rule for that. Does it represent proportional or non-proportional? Remember, if you have something, if you have to multiply and then add, that's non-proportional. If you multiply and add, if it's 2 steps. Okay. Number 6. This one's about selling more pizzas now. So this is a lot like the one we did before. Mario's Pizza sells large cheese pizzas for $9 and will deliver locally for a charge of $3. Okay, so if I do a $9 pizza plus $3 delivery, that is going to be a $12 charge altogether. If I buy 2 pizzas, that's, y'all hear my pit bull in the background maybe? If I buy 2 pizzas, that's $18 plus the $3 delivery. That's going to be $21. If I buy 3 pizzas, that's 3 9s, that's $27. Plus the $3 for delivery, that's $30. All right. Again, last time I did not draw a graph, but I guess I can this time. Again, treat these like points. That would be 1 and 12, 2 and 21, 3 and 30.